Oblique asymptotes occur when the degree of the top is higher than the degree of the bottom. An oblique asymptote is just a line or a curve that your graph gets close to as you go far to the right and far to the left. Just like with horizontal asymptotes, oblique asymptotes are also y equaling something. And just to be aware that your graph, your function, can cross an oblique or horizontal. It only tells you what happens as you go far to the right and far to the left. It doesn't tell you anything what happens in the middle of your graph. On this particular problem, we will have an oblique asymptote because the degree of the top is greater than the degree of the bottom. But we're still going to go ahead and graph everything pretty much the same way. We're going to go ahead and find our domain. So we got to go ahead and factor the bottom. In this case, it doesn't factor. So our domain is going to be all real numbers except what causes the bottom to be 0, which is 2. Then you need to go ahead and look for vertical and horizontal, vertical asymptotes or holes. So vertical asymptotes are what causes the bottom to be 0 if you don't have any common factors. We have no common factors here, so we have no holes. But we will have a vertical asymptote at what causes the bottom to be 0, and in this case it's x equals 2. Then we need to go ahead and find our y-intercept. And that's when we plug in 0 for x. Plug it in here, 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 and we get a -3 on top, then over a -2 on the bottom, so we get a y-intercept of 3/2. Then we need to go ahead and plug in 0 for our y to find our zeros. When you plug in 0 here, the only way your fraction is equal to 0 is when the top is equal to 0. So what would cause the top to be 0? Well, you'd have a -1 here, and then you'd have to add a 3, divide by 2, and so you get your zeros to be a -1 and a 3/2. We had already said that we're going to have an oblique asymptote because the degree of the top is greater than the degree of the bottom. So we don't have to worry about the horizontal. When the degree of the top is greater than the degree of the bottom, you can always go ahead and find your oblique asymptote by using longhand division. In this particular case, since we're dividing only by an x plus a number or x minus a number, we could use synthetic. Your oblique asymptote is always going to be y equaling your quotient, whether you are using longhand or synthetic. It's always y equaling the quotient. You're going to often have a remainder, but we don't care about the remainder. So to work this out, I would go back and use my original problem, put the 2, the -1, and the 3 after your half box. We're going to put 2 in the bottom, or in the half box, because that's what causes the bottom to be 0. Remember, you got to drop down the first number, multiply, add, multiply, add, and the last number is your remainder, so your oblique asymptote is going to be y equaling your quotient, which is right here. So in this case, it's y equaling your 2x plus your 3. Then we want to go ahead and graph our vertical asymptote, our oblique asymptote, plot our zeros, plot our y-intercept, then go ahead and put in any holes if we have any. When we do that, we would have something like this. Our vertical asymptote of x equals 2. This is oblique asymptote is the equation of our line, crossing our y-intercept at 3 and having a slope of 2, and that's what we have right here. We have our 2 zeros plotted, and we have our y-intercept plotted. Then you want to go ahead and graph this on your y-axis, on your graphing calculator, and then draw in your graph so it goes through all this here but does not cross the vertical asymptote. So when you do that,